I'm Max. So I spent the last couple of weeks building this thing called Denali. It's basically a version control system, but it works a bit differently than Git. Right now, it's focused on something I'm calling cells. Think of a cell as like a project inside a project or a repo inside a repo if that makes more sense. Why does this even matter? Well, most real systems are actually built this way. Take an operating system. You've got the bootloader, the kernel, a bunch of libraries, drivers. They're all separate pieces, but they depend on each other. Or think about modern web apps with microservices. Same deal, small components that work together in a bigger system. Here is the thing, Git wasn't really built for this. It's great for single repos, but when you've got nested interdependent projects, it gets messy real fast. Like, picture this. You're working on the front end while the backend team is making changes. Something breaks, maybe some shadecode or dependencies got updated. Now, you can't push because the remote has commits you don't have, so you pull, and boom, merge conflicts. But here's the annoying part. Git doesn't make it easy to just roll back the backend to an older version while keeping everything else current. That's where something like Denali could actually help. The core idea is pretty simple. Each cell has its own history and snapshots, so when one part breaks, you can just pull an older version of that specific cell and keep working. Everything else stays up to date. And in your project's config file, you can lock a cell to a specific snapshot, so Denali won't pull any other version of that cell, it just stays put. Now, full disclosure, the remote stuff isn't built yet, so right now Denali is basically a backup system with the named snapshots. All your data gets saved in a Denali directory in your home folder, which makes it super easy to copy or share entire projects at once. There is also a copy command that lets you grab just one project or cell, snapshots, history, everything. It creates a new .denali object store wherever you want and copies all the necessary data over. And if you want to load from a custom .denali store, you can use a from argument. Just make sure the path ends with .denali. So the way Denali stores stuff is pretty similar to Git's object store, just with some tweaks. I'm using Blake 3 for hashing because it's way faster, and ZSTD for compression, same reason. If you are not super familiar with how Git stores data, the basic idea is this. The same data always produces the same hash. That means you don't have to worry about duplicate data or manually computing diffs or any of that. Here is how it works. You feed a file's contents to the hasher and Denali names the object using that hash. If the data is duplicated, multiple trees just point to the same object. If the hash changes, the data changed. Simple. This makes it really easy to track history, detect changes, and store snapshots efficiently without duplicating a ton of data. And you don't even have to think about naming stuff because only identical data produces the same hash. No naming conflicts. So when you run Denali save, it walks through your project, compresses every file, hashes them, and saves everything in the object store. When you run Denali load, it finds the data using those hashes and restores it back to your project directory. That's Denali in a nutshell. Remote features are coming eventually, but right now it already handles snapshot backups, modular history, and easy project or cell copy. Fair warning though, the load function is like 200 lines of pure chaos. I built this whole thing in 2 weeks, so yeah, there's definitely some refactoring in my future. But hey, it works, and that's pretty cool. Anyway, thanks for watching and have a great day.